So now let's talk about a concept of functions. What are functions and why do we even need them, right? So before we actually start with functions, let's understand this word, dry. Dry. What is dry? What does dry stands for and what it actually means? So dry stands for don't repeat yourself, right? If you have done something once, why do you want to do it again and again? So actually this is called as a dry principle. Dry principle, right? There's a dry principle. Dry principle says that if you have already done a task, why do you want to do it again and again, right? And there is like a lot of sense in this. There is a lot of sense in this. So let me first of all give you an example and try to ask you guys that do you guys agree with what I'm trying to say or not? So let's say you are writing a piece of code. Let's say you're writing a piece of code, okay? Now, let's say in this piece of code, let's say this is some index.js file. In this piece of code, somewhere you wrote the logic, to check if the number is positive or not, right? Let's say you are implementing some like you were trying to implement some software or you were trying to do something, and in between doing that you actually somewhere wrote a piece of code, right, where you tried to write the logic to check if the number is positive or not. How will you check a number is positive or not? If the number x is greater than 0, it is positive, else it is negative, right? Simple logic. And let's say you have to do this thing 3 times. You have to do this same thing 3 times, okay? You have to do the same thing 3 times, okay? What you are building, it can be hypothetical. I'm just taking a hypothetical situation that you were trying to build something, and during that, like during the process of building it, you were required to write a logic to check if the number is positive or not. And this is like very simple to do, okay? So if I will ask you to do it 3 times, you will just write the same logic, copy paste 3 times, okay? Now let's say there are some situations that can happen. Situation number one. Situation one. Let's say instead of writing the correct logic, you wrote something wrong. Let's say you wrote something like x greater than 1. You wrote something wrong and you wrote the same thing wrong everywhere, right? Instead of writing the correct logic here, you wrote it in a wrong way and you wrote everywhere everything wrong. Now the problem is when you will identify that, oh, my bad, I wrote a wrong logic, then you have to rectify it in this place, then rectify the same logic again here as well, and rectify the same logic again here as well. Are you guys able to get this point? Right? If we make a mistake and we just and initially we have just copy pasted our code, we have to rectify it everywhere. Okay. There can be another situation that let's say you didn't make a mistake. You didn't make a mistake. Let's say the requirements changed. So situation one was mistake. Situation two was requirements changed. Okay. Now let's say the requirements changed such that now you don't need to detect whether the number is positive or not. Let's say you want to detect whether the number is even or odd or not. Now the requirements changed. So again the code change will happen. You have to change the code here here and here, everywhere. You have to repeatedly change things. Can I say that? And this is happening because you just repeated yourself. You copy pasted your code. How about a mechanism using which we can avoid this? How about a mechanism using which we can avoid this? Right? So that's what dry principle says. That don't repeat yourself, because if you will repeat yourself, situations like these can occur. Situations like these can occur. Right? To rectify this, we have functions. Now, functions is not just a computer science concept. Functions as a concept exist in mathematics also. I'm not sure how many of you, but few of you must have definitely seen an expression like this. Y is equals to f of x. Some of you might not have seen it. Some of you might have seen it. So what is this? So actually, in simple terms, a function, let's say this is the name of the function. This is name of the function, right? A function is a black box. A function is a black box, right? That is what is present inside the function. The outside world might not know, or maybe they don't care, right? There can be some logic that has been implemented inside a function. All you care about is using a function. And how do you use a function? You provide some input to the function, then the function processes that input, and then the function gives some output corresponding to the function. Same thing happens in mathematics also. So this x is actually the input that you provide in the function, and this y is the output that the function, after processing your input, gives. For example, let's say you have a function to calculate square root. What you will do? You will provide some value x. It will do some calculation, something we don't care. And at last, it will give you root x. So for example, if you pass a value 9, it will return you a value 3, because square root of 9 is 3. Right? So this square root function is going to be a black box. Right? So functions are black box, simple black box. What is inside the function? Technically, we don't care. It just takes some input, it processes the input somehow, and then gives the output. Now, who knows the logic of function? The person who has implemented the function. The person who has created the function knows how the function works, right? But for the outside world, it's like a black box. We just know what the function does. We just provide it an input and gives it it takes an output from it. It's similar to something like how banks work. Now, when you go to a bank, let's say you want to submit a check. Now, what you do? You take your check, and you take a slip, and you just submit the check and the slip to the bank manager or the bank employee. Now, how the bank employee actually handles the check, do you know? No, we don't know. Do we care? No, because all we care about is how to submit a check. And once we submit the check, they give us an acknowledgement receipt. That's our output. And we believe that now the check will be processed. So as an end customer, we don't know how exactly internally banks work. But who knows how bank works? The bank employees knows how they have to work. The bank employees knows that if they receive a check as the input, how they have to process the check and what output they have to give. That's the similar thing about function. The person who will be implementing the function knows about the logic of the function, right? So technically, if we see with our perspective as programmers, we have two choices. First, we can create our own functions, right? We can also create our own functions, or we can consume others functions, right? So in different programming languages, we have some inbuilt functions. In different programming languages, we have inbuilt functions. For example, in JavaScript also, we have a lot of inbuilt functions, right? So we can either directly use them. For example, in JavaScript, you have something like math.sqrt, right? What this function actually does is it calculates square root, right? We have not implemented it. It's an inbuilt function. Who has implemented it? The developers of JavaScript has implemented it. Now, do we care how does it work? No, we don't care. When we have to calculate square root, we will just give this function an input and it will give us an output, right? And to be very honest, the syntax is going to be a lot same as like the maths. Like you can do something like y is equals to math dot square root of, let's say, 9. It will return your value 3. It will give you a value 3. These are inbuilt functions. So we will be having a lot of inbuilt functions. We don't need to remember all of them, but some important ones we will definitely discuss. Okay. Apart from that, we can create our own functions as well. Now, you might be thinking that, okay, sir, now we have two theories in our hand. One theory is this repetition creates problem. One theory is function is a black box. Now, if we use functions, then we can store our logic inside a function, right? You can store a logic inside a function, and doesn't matter how many times you want to use it, you will just call the function, right? You will just call the function. What I'm trying to say is, let's come back to the same situation. That we have an index.js file and we were expected to implement the logic of calculating even, odd number, or let's say positive, negative, something like that 3 times. So I'm not going to copy paste my logic again and again 3 times. Instead, what I'm going to do is I am going to segregate out my logic in some function x. And wherever I have to use it, I'll just say y is equals to f of x, z is equals to f of x, r is equals to f of x. Now the best part is, let's say there is a mistake in my logic. Then if there is a mistake, then we need to rectify only once. We need to rectify our mistake only once, because we are everywhere just using it. The implementation is done only once. The logic is only present once. In the previous situation, my logic was present, copy pasted 3 times. So we have to change it everywhere. Whereas now, my logic is just present here and I'm using the function again and again. So I need to just rectify my logic at one position and everywhere it will be changed. Apart from that, if we need to change the logic, we need to change it only once, right? We need to change it only once. right? If we need to change the logic, then also we need to just change it once, right? So this is the essence of functions. I'll be showing you a coding implementation. But this is the essence of functions, that what actually can be done with the power of functions. Functions actually segregate out your logic at one position so that you don't have to repeat yourself. Wherever you have to use this logic, you just call this function. So you can say that this is where you implemented and this is where you call the function. Okay. I'll be showing a coding implementation, but this is the essence of functions, and that's how we will implement the dry principle in our logic. That is, don't repeat yourself. See, we are not repeating ourselves now, because by repeating there is a lot of problems that can occur. For example, let's say you wrote your logic of checking whether the number is positive or not 3 times. Let's say in two positions there was a in two positions there was a mistake, but it was correct in one position. But you have to debug it everywhere, right? Whether it is wrong here, whether it is wrong here, whether it is wrong here. So you have to debug it everywhere. So debugging takes a lot of times, right? It will be a lot of hectic process that you have to go through for maintaining the code. Whereas if you just implement the logic once and just use it everywhere, it will be super easy to do. It will be super easy to do. Now let's see. Now let's see how can we create a function in JavaScript. Functions in JavaScript. Okay. So to create a function in JavaScript, first of all, let's understand the structure of a function. If you see functions here, so function has a name of the function. There are some inputs that are involved, right? And there can be some output that is involved, right? So how do you make a function in JavaScript? You write the keyword function. So there is a keyword function. There is a keyword function. Then you put the name of the function. Let's say my new function, right? You can put some name of the function just like you put name of a variable. And then you put a pair of parentheses. Then you put a pair of parentheses. Similar to this, in the pair of parentheses, you put the input. So there can be one input, there can be more than one inputs, or there can be no inputs. Depending on that, you will pass your input 1, then comma input 2, then comma input 3. So let's say this function has 3 inputs. We can have more than 3 inputs also. And then what do? You will initialize a set of curly braces. What these curly braces are going to do? They are going to define a block for a function. Okay. And then we will be writing some logic of our function. Okay. We will be writing some logic of our function. Now, in this logic of a function, at last, when your logic has been processed, because the function can give some output, right? The function has to give some output, that is this value y. So at last, when your logic is done, you use the keyword return. There is a keyword return. Return means you are going to return a value from the function, and then you return some value. So let's say I'm going to return my name here, Sanket. You can return anything depending on your logic. What your logic demands to return, you will return that thing. You'll write the keyword return space and whatever value you want to return. If you want to return 10, you can return 10 based on that. So whatever value you have to return, one value you have to return, it will return that. So what is the syntax? You write the keyword function space, you put the name of the function, you put a pair of parentheses. Inside parentheses, you put your inputs, comma separated. If there is no input, then there won't be anything that you have to add here. If there are, let's say, 2 inputs, you will add 2 inputs, 3 inputs, 3 inputs, whatever it is. Then you put a set of curly braces to define the block of a function. And inside this block, you are going to write your logic. Once your logic is done and you want to return a value out of the function, you will write the keyword return and then you put the value that you want to return followed by a semicolon. This is how you create a function. This is how we create a new function. This is how we create a new function. So let's take an example. So let's say I want to create a function. To check if the number is even or odd. Okay. So let's say we want to create a function to check if the number is even or odd, right? So what we will do, we will write a function, a keyword function. Name of the function is even or odd. Now we have to check whether the number is even or odd. That means it will take the input of a number. So I will say, let's say num, and I will put a pair of curly braces. I will say, how to check whether the number is even or odd? We will say if num mod 2 is equals to 0, we will say return true, right? Because if the number is divisible by 2, that means it is even. So let's say, let's name the function as is even, right? Is even. Instead of saying whether it is even or odd, we'll just check whether it is even or not, right? If it is even, we will say true. If it is not even, so we will say just say false. Okay. So we'll say else return false. That's it. And now if I want to check, let's say we have a number, let x is equals to 10. We will say if is even, we will call the function is even and pass the number x. Right? So if is even gives you a value true, you will say console.log even, right? Something like this we can do, right? So let me even try to write this code in front of you on VS Code, and then we will try to discuss more things on this code, right? So let's try to write a function. So we'll say the keyword function, then the name of the function is even, and then you put a value, let's say num, right? This is going to tell you what is the input. Okay. We will say if num mod 2 is equals to 0, we return a value true, else we return a value false. Okay. And then here what I can say is let x is equals to 10 if, now we will call the function if is even, or let's say, let's make it simple, let result is equals to is even of x. If result is true, console.log even, else console.log odd, right? And if you run it, we are getting even. Now the best part is, let's change the input to 101 and run it again. You get a odd, right? And now, in fact, I can just say that for let I is equals to 1, I less than equal to 20, I plus plus. Let's see among the first 20 numbers, what all numbers are even numbers. Okay. So we will say let result is equals to is even of I. That is whether the ith value is even or not. And we can say if result is true, we can say console.log I, and we can print the string even, else console.log I comma odd. That is the ith number is odd. Okay. So let's now run it. Let's now run it. And you can see 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, 7 is odd, 8 is even, and so on and so forth. Right? So now what happened? I could have called, like, wrote a logic, this if else, I could have written it 20 times. I could have written 20 times, right? Instead of writing it 20 times, I just wrapped it inside a function and then just called it 20 times. Okay, so let me give you one easier demonstration. Let me give you one easy demonstration. Now let's say I want to check. Let's say I want to check whether now I have some logic. Now I have some logic, right? Let's go by the basics. I have written a function is even. Now I want to check this like for three numbers, any three numbers. Let x is equals to 10. Let y is equals to 20. Let z is equals to 81. Okay, z. Now, what was the main thing about functions? In functions, we said that we will just wrap our logic somewhere. We will just wrap our logic somewhere. And wherever we have to use it, we will just use it. So we'll say if is even x. Right? So we just called our function, right? We just called our function. We can say console.log x is even. Else we'll say console.log x is odd. Can I say that? And now I can just call it three times. Right, I can just call it three times. Now once I can call it for y, once I can call it for z, and let's put y here, and let's put z here. Right, simple thing. Now otherwise what you might have to do, you might have to write your logic three times. You might have to write your logic three times, and if there is a mistake in the logic, you might have to rectify the logic three times. Right? So this is the essence of functions. If you wanted to do without functions, let's say you want to do the same things without functions. So without function demo. Right? So let's say I want to do it without functions. So let's say I have three variables. Right? Then what will I do? I will say if x mod 2 double equals to 0, I will say console.log x is even, else console.log x is odd. Right? If let's say I want to do it without functions, I have a problem that I will be given three numbers and I have to check which all of them is even, which all of them is odd. So without functions, you could have done this and then just copy pasted this logic three times. Once for x, then for y, and then for z. Can I say that? This could have been the approach without functions, right? This could have been the approach without functions. Right? Now the problem is, let's say by mistake, I made a mistake here, y mod 3. Instead of doing mod 2, I made a mistake here. Right? Let's say I made a mistake here. Now I have to go everywhere and check for my logic. Oh, where is my mistake? Where is my mistake? Where is my mistake? Right? This is like a lot of repetition in the code. This is a lot of repetition in the code. Right? If I want to rectify this, what I will do, let me clear this whole file and let me write a function again. How do you write a function? You say function keyword. There is a keyword function. Then you say is even or odd. This time let's write it like is even or odd. You will give a number num, because every time you have to check whether a number is even or odd. So input should be given that number because the evaluation is expected to be done on the number. We say if num mod 2 is equals to 0, let's say I return even. Instead of true false, let's say return even odd. You can even return a string, you can return a boolean, you can return any valid JavaScript type. Okay. Else, if the number is not even, you can return odd. You can return odd. And now see how easily we will be able to do everything. These are the three numbers. These are the three numbers. We will say console.log x is, and we call the function is even or odd x, and then just copy paste. Y is even or odd y. Z is even or odd z. See how clean the code is. Now if there is a mistake, there is a mistake at only one position, because we have implemented things one position, and I'm going to use it anywhere, any number of times. If I have to change the logic this time, let's say instead of even or odd, I want to check whether the number is positive or negative, then I have to change the logic at only one position. If you run it, x is even, y is even, z is odd. See, so how clean this code is in function demo 1, and how bad this code is in function demo without function demo. So this is the essence of functions. You will wrap your logic that is going to be used at many places once, and then use it wherever you want, whenever you want. Now the best part about function is, if I have this function written, let me make a new file, function demo2.js. I have this function written, and let's say I have to solve a question, check, or let's say print all the even, or let's say check which numbers are odd and which are even in between 1 to 50, between 1 to 50, between 1 to 50. So let's say guys that we have to check which numbers are odd and which are even in 1 to 50. Now if I have to check this, so what you will do, you will do something like, what will noob will do, a noob will do something like console.log 1 is even or odd 1, then call the function again, 2 is even or odd 2, then call the function again, 3 is even or odd 3, so on and so forth. At last console.log 50 is even or odd 50, right? You will call the function 50 times, right? This will be done by noobs. Noob karenge aise. But we are smart people. We know that if you want to repeat a process, see, there is a repetition, right? What is the essence of repetition? The function is getting called again and again. This is the essence of repetition. So instead of calling the function and again, how about you bind it inside a loop? For let I equals to 1, I less than equal to 50, I plus plus, and then you say console.log I is even or odd I. See, the same thing that you would have done in 50 lines, we did it in 3 lines. If you run it, 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, and it will go up till 50. So that's the difference between repeating a process and binding a logic separated out somewhere, right? So now let's try to talk about few common questions around functions in JavaScript, right? Why we are doing return? Can we not use console.log? Can we not use console.log? Right. So in order to answer this question, first of all, we need to understand console.log. We need to understand console.log. We need to first of all understand what is console.log. If you see the syntax of console.log, we write console.log, then put a pair of parentheses, and then write some values inside it. And then what console.log does is, it actually prints the value on your console. Let's say it can be your browser console, it can be your VS Code terminal. Anywhere it just prints the values. So technically console.log is also a function. This complete thing is also a function. To be precise, actually what is there? What is happening is console, just this console is a object. It's a JavaScript object, if you remember, key value pair. And in this console object, you have a key named as log. And with this key log, there is a function attached. So if I just give you a kind of like a demo, so console object looks something like this. It's an object key value pair where you have a log key and the value is a function. And a value is a function, right? That makes this whole console.log in itself a function. So when you say console, you access the console object. When you do console.log, you access this log key, and to this log key you have a function associated. So when you call this with some arguments, it executes its functionality. Now, what is the functionality of console.log? What is the functionality? What is the logic of console.log? The logic of console.log is to print something on your screen. Okay. Now, you might be thinking, okay, if console.log is a function, then does it return any value? Does it return something? Yes, it returns something. It returns undefined. It returns undefined, right? It returns undefined. So if you remember, wherever we were using the functions, we can store the values of a function in a variable, right? So what you can do is, in order to demonstrate this, you can do x is equals to console.log sanket. Okay, console.log sanket. Now this sanket is the value that you are going to give the input to the console.log function. What is this functionality of console.log? It will just print this value sanket on the terminal, but it will also return a value to the variable x. So if you see if you try to see what is there inside x, then x will be having a value undefined. X will be having a value undefined. So let me demonstrate it in front of you. Let's see one more demo. So console log demo.js. So let's say if we say let x is equals to console.log sanket. Now if you see, sanket is the input value given to function, right? Sanket is the input value given to the function, and the function actually just print the given input value on the screen and then returns undefined no matter what the input was. So whatever input you give, it will always return undefined. So technically if you do console.log x to see what is there, what value is there inside x, if you run it, you see you print sanket and then you print undefined. Let me run it again. You print sanket and you print undefined. Why? Because the moment you print console.log, the moment you call console.log, whatever value you have given it as the input, it just prints that value and then by default returns undefined. And what did I tell you about functions? Functions are black box. So we have not implemented this console.log function. And to be very honest, we don't care. All we care is what is the input expected, what is the functionality it is going to execute, and what is the output expected. So the input is anything, like you can give sanket, 10, 20, boolean, some true, anything. The functionality is whatever input you will give, it will print that input. And the output expected is always undefined. It will always return you undefined. Always and always it will return you undefined. That is why if you in Firefox or Chrome, if you will do console.log and then print some value, it also prints a undefined under the hood, because it actually returns the undefined there, right? So just like console.log, you have many more inbuilt functions. So if I talk about inbuilt functions.js, I'm giving you some inbuilt functions. For example, let's say let answer is equals to math.sqrt of 100. Console.log answer. Console.log answer. If you run it, see, we are getting 10. So I have not implemented this square root, but it is already implemented by default inside JavaScript. So we can just directly use it, right? What is the input expected? It will be expecting some number. What is the functionality? The functionality is it will evaluate the square root of the number. And what is the return value? The return value is the square root of the number. Now you might be thinking that, okay, whenever we call a function, we try to store the value of that function in some variable, right? But we don't store any value of console.log. Generally, till now in the course, whenever we do console.log, we don't store its value, just like we are storing it here inside X. We never did it. Why? Because it's like, if you go to the bank, you submit your check, you take the acknowledgement slip. Now it's on you, right? Whether you keep that acknowledgement slip with yourself or you just throw it because maybe you don't need it anytime. So if the function is returning something, it's good for them, but it is completely dependent on us who is calling the function, that whether we want to store the value or do something with the returned value or not. That is why we don't have to do anything with the return value of console.log. So that's why we never store it anywhere. We just use the functionality of the function. But for square root, it makes sense for us to actually store the value. So we are storing. So it's on us. Function will always return something. Function will always return something. It's the choice of the user whether we want to store that returned value or we just want to keep it as it is. So now the original question, why are we doing return? Why don't we just console.log? Because let's say, because if you do return, you can store that value somewhere. You can store that value somewhere in some variable and use that variable later. If you just print that value will get printed on the screen. You cannot store that value, right? You cannot store that value. So that's why it's important to do return. That gives us another question. What if I don't return anything from function? What if I don't return anything from the function? In JavaScript, I'm talking with respect to just JavaScript. Different languages handle it differently. In JavaScript, if you don't manually return something, it automatically returns undefined, right? If you don't manually return something, for example, if you don't return any number, null, string, undefined, object, anything, if you don't manually write your return keyword followed by some value that you want to return, JavaScript will automatically return undefined there. That is the essence of JavaScript. So in JavaScript, a function always returns something. If you are not logically manually returning something, JavaScript will by default return undefined. So let's see a situation. Function demo3.js. Let's say I write a function. Anything like, let's say function fun. Okay. Currently this function fun can, or let's say function welcome. This function welcome expects a name. Okay. And then let's say we do console.log hello comma name welcome to JavaScript. Welcome to JavaScript. And then I don't manually return anything. See, I don't manually return anything. Now let's say if I do let result is equals to welcome and let's say Sanket, and I do console.log result. Okay, let's say I do console.log result. Let's see what happens. If you run it, see it says hello Sanket, welcome to JS. But after line number 5, line number 6 gets executed, it returns undefined. Why? I didn't manually return anything. So JavaScript by default will return undefined. Okay. So let me show you how the code execution will happen. Right. Let me try to debug it in front of you. Later, I will also teach you how you can debug yourself in VS Code. But for the timing, let me just show you. So I'll put a breakpoint here. I'll put on run, start debugging. Okay, let's see now. Okay, let's see now. So let's go inside this function. So we are on line number 5. We go inside the function. See, now we are inside the function. Inside the function, we have this variable name, which is having a value Sanket. What is the statement that we are executing? Console.log hello and something. So see, hello Sanket, welcome to JS got executed. You can see the output here, right? Hello Sanket, welcome to JS. And now the function ends. The function ends. Now you can see what is the return value. Because you have not manually returned anything, the return value is undefined. So if we move forward, can you see in the result variable you have undefined here? In the result variable you have undefined, right? And then you print undefined. That's it. So this is how the code execution works. If let's say you don't manually return anything, but let's say if you manually return bye bye, something like this, you manually return bye bye. If now you run it, you can see bye bye will get printed because now the function welcome will return a value bye bye, which will get stored inside result, and boom, when you print result, you get bye bye. That is the essence of how exactly function returns a value. Small concept, there is a very small concept that you need to understand. Let's say I wrote a function add. It will take two numbers, let's say x and y. It takes two numbers x and y. And let's say it just do a simple thing. We say let c is equals to x plus y and return c. Okay, return c, simple function. It is going to add the two numbers that you are going to give. Okay, now when you call, let's say let x is equals to 10, let y is equals to 20, or you can even change the names while calling, better to understand. And let's say you say let result is equals to add a comma b, console.log result. Okay, console.log result. Now there is a very interesting thing, although very simple thing to actually call out. What happens is when you are defining the function, this is the position, or you can say this is a place where we are defining the function, place where we defined the function, right? And this is the place where we call the function, place where we call the function, right? Now in the place where you define the functions, these inputs are called as parameters. These are called parameters. That is the place where you define the function, right? The place where you define the function, the inputs are called as parameters. Okay. Now, whenever you implement that function, you just use these parameter variables and just implement your function. But when you are calling the function, it's not necessary that you have to make the variables with the same name xy, right? It's not like that. Variable naming doesn't matter. You can name the variables as a, b. What will happen is the value of a, actually when you write a here, the value of a, which is 10, that value 10 and this value 20 gets passed here. And on the position where you are calling the function, these input values are called as arguments. Okay. So when you define the function, these input values are called as parameters. When you call the function, these input values are called as arguments. You don't need to keep the name of the parameters and the arguments always same. You don't need to do that, because the moment you create a variable, let's say a equals to 10, the value of a is passed here and the value of b is passed here. right? It's not mandatory that you put it X or Y. No, it's not mandatory. You can keep it A, B, you can keep it F, G, anything you want to keep, right? So when are we defining the function? We will call these things as parameters. When we call the function, we call these things as arguments. Argument is something that is passed. Parameter is something that is expected or defined. This is the basic thing. This is the basic thing, right? And as I said, wherever you have defined a value, now you can do one more thing. Like you pass one value as A and let's say hard code this value like 30. So what will happen is, what is the value of A? 10. 10 will be passed here and you have already defined 30. So X will get a value 10 and Y will get a value 30. Y will get a value 30. So let me give you a demo. Let me give you a demo and actually demonstrate this. So let's say function demo4.js. Let's say I write a function add x comma y. We say let c is equals to x plus y, return c. And then here we say let a is equals to 10, let b is equals to 30, let result is equals to add a comma b, console.log result. Okay, if you now run it, you can see the value is getting 40. Let's try to debug it. Let's try to debug it. Okay, see, you make two variables a and b. See, can you see these two variables a and b? A is having a value 30, b is having a value 30. A is having a value 10, b is having a value 30. And we have defined a function add. See, we have a function add which has two parameters x and y. Okay, when you call add, now see, we are inside the add function. When you call add actually, see, the value of x is 10, value of y is 30, right? Value of x is 10, value of y is 30. And then you create a variable c which is having a value 40, and then you return c. So inside your result, you are having a value 40, and then you print your result. That's it, right? So in the calling side, here a and b are arguments. Here x and y are parameters. Parameters is something defined at something which is defined. Argument is something that is actually passed. Let's say I do something like this. Let me comment all of this, or we can keep it. And let's say now this time I do console.log, and inside console.log I am doing add 9 comma 1. Okay, now let's see what is happening on line number 11. Let's see one by one. We are calling console.log. That means whatever is passed inside console.log, this expression will be evaluated, right? So let me write here, we are passing add 9 comma 1 inside console.log. So first of all, add 9 comma 1 will be processed. What will be the value of add 9 comma 1? What will the function add return if I pass 9 and 1? So add 9 comma 1 will return 10. It will return 10. And then once we have the value processed as 10, then console.log will print 10. Console.log will print 10. So if you run this code, you can see you're getting 10 printed. It's not like it will print add 9, it will print add 9 comma 1. No, because add is technically a function. So it will recognize that it is a function. It is not a string because, as I said, it's not a random text. If you want to define it as a string, you need to wrap it inside a pair of double quotes. If you wrap it inside a pair of double quotes, now it's a string. Now you are not calling a function. Now if you run it, it will print this, right? But we don't want to print it as a string. We want to evaluate the function, and hence it will give us 10. Now what if I pass one more value here? What if I pass one more value in add? We were expecting only two arguments. The parameters are defined two, so we were only expected to pass two arguments. But now I passed one more. What will happen? If I run it, it will only process the two. It will only process the two. Right? So there will be a lot of cases when you will feel like, what will happen when I do this? What will happen when I do that? Right? So it is the best practices. Try to do it. Try to see and execute it. What happens? Right? If you want to process the third output, a third input, then you have to manually handle it here. You have to add it as a parameter and then do it. Because there can be a lot of cases. You might feel that, what if I don't put function keyword? What if I don't put curly braces? You have to see what happens when you change something in the code. You have to see the consequences that your actions can do. That's how the best way, that's the best way to learn programming, and that's the best way to get started with programming. You need to actually experiment. Just think about, like, when we were young and we used to get mobile phones, nobody taught us how to use mobile phones, right? What we used to do, we used to experiment. What will happen if I go to this menu? What will happen if I press this button? What if I press these two buttons together? What will happen this, what will that's how we learn how to use mobile phones. Nobody taught us, right? Because it's not that complex if you experiment. So that's what we can also do here. So let's try to solve this question. The question says that you have been given a number x and you have to write a function to determine whether the number is a prime number or not, right? So you have to somehow like write a function with a signature like this. Maybe you can name it as is prime. It will take an input value x. It will take an input value x and then somehow evaluate whether x is prime or not. Okay. So for example, if I will give the input as x is equals to, let's say, 13, so my output should be true, that yes, x is a prime number. If the input is something like x is equals to 54, then my output should be false, that x is not a prime number. It should be false. Okay. So let's talk about it and actually try to see what can be done, what cannot be done, because to be very honest, it's a fairly simple thing to evaluate, but it is going to give us a good, I would say, it's a fairly simple thing to evaluate, but it is going to give us a good perspective on functions. Okay. So first of all, we need to decipher the logic. Okay. Let's decipher the logic. The main problem here is how to check if a number is prime or not, right? So in order to actually think and try to form a logic to check whether the number is prime or not, we need to figure out the fact that what type of numbers are prime, what type of numbers are prime. So what are prime numbers? We say x is equals to 5 is a prime number, x is equals to 11 is a prime number. Why we call them as a prime number? Because primes are only divisible by 1 or the number itself. Simple definition of prime. That, let's say, we say that 11 is a prime number because only 1 and 11, there are only two numbers that can divide 11. Apart from that, there is no other number that can divide 11. This is why we call 11 as a prime number. Okay. So if, let's say, I have been given a number for, let's say, x is equals to 12. I want to check whether 12 is a prime number or not. Right? We want to check whether 12 is a prime number or not. So when the number 12 won't be a prime number, when it is divisible by something other than 1 and 12. 1 to definitely will divide 12. 12 will also divide 12, right? If there is at least one more number, if there is at least one more number apart from 1 and x that divides that divides x completely, then x is non-prime. And what are non-prime numbers? We can say it's a composite number. Okay. So what I can say is, if I have to detect whether 12 is a prime number or not, what I can do is 1 to will definitely divide 12. So we can start with 2. I will check. Can 2 divide 12? Yes. 2 can divide 12. And how can I check whether 2 can divide 12? I will see 12 mod 2, whether this value is equals to 0 or not. So we can say 12 mod 2 is 0. That means we definitely have at least one more number apart from 1 and 12 that can divide 12, and hence 12 is non-prime. Let's take few more examples. Let's say something like, um, let's say value 9. Okay. So 1 will definitely divide 9. 9 will also divide 9. So let's try to figure out with the values from 2 to 8 that anything between 2 to 8 divides 9 or not. So we will try with 2. Can 2 divide 9? What is the value of 9 mod 2? 9 mod 2 is 1. That means 2 cannot divide 9. 2 cannot divide 9. Then we try with 3. Can 3 divide 9? Yes. Because 9 mod 3 is 0. So 3 divide 9. That means we have at least one more number apart from 1 and 9 that can divide 9. We have at least one more number apart from 1 and 9 that can divide 9, and hence it is not going to be our answer. Right? So, and there can be different things. For example, let's take one more value. Let's take something like 49. We have to detect whether 49 is a prime number or not. So we will start with, like, 49 is definitely divisible by 1 and 49. So we want to find at least one more number that can divide 49. So we'll start with 2. Can 2 divide 49? No. Can 3 divide 49? No. Can 4 divide 49? No. Can 5 divide 49? No. Can 6 divide 49? No. Can 7 divide 49? Yes. Because 49 mod 7 is going to be 0, because 7 into 7 is 49. Right? So that means 49 is also non-prime. Let's take one more example. Let's take 13. Let's take 13. So we again start with 2. Can 2 divide 13? No. Can 3 divide 13? No. Can 4 divide 13? No. Can 5 divide 13? No. Can 6 divide 13? No. Can 7 divide 13? No. Can 8 divide 13? No. Can 9 divide 13? No. Can 10 divide 13? No. Can 11 divide 13? No. Can 12 divide 13? No. And that's it. There is no other number that you need to see, because 13 to will eventually divide 13, right? So from 2 to 12 we checked everything, and no number was able to completely divide 13, hence 13 is a prime, right? So what is the final logic that we got? If let's say we have a number x, we have to check whether x is a prime number or not. So we start with 2 and try to divide x. Then we go to 3 and try to divide x. Let's say 2 didn't divide x, 3 didn't divide x. We go to 4, we try to divide x. We go to 5, we try to divide x, and so on and so forth. Up till x minus 1. We will check, can x minus 1 divide x, right? If any of the numbers, any of the numbers between 2 to x minus 1 was able to divide x, we can say x is non-prime. Otherwise, if no number was able to divide x from 2 to x minus 1, that means x is a prime. For example, let's say you got a 12. You try to divide 2 with 12. Can 2 completely divide 12? Yes. So the moment you find any number, the first number that you found from 2 to x minus 1, the first number that we found in this range that can divide x completely, we immediately will return false. We will immediately return false. That is, we try to put a loop because it's a repetitive process, right? What is the essence of repetition here? What is the repetition part here? Repetition part here. That you go from 2 to x minus 1. You go to all the numbers from 2 to x minus 1. You go to all the numbers from 2 to x minus 1 and try to divide x. Try to divide x. Try to divide x. Try to divide x. So what I can do is, I can say for let I is equals to 2. You are going to start with 2. I less than or equal to x minus 1. You have to go till x minus 1. I plus equals to 1. And every time you will check if x mod I is equals to 0. The moment you find any value of I in this range, you found any value of I that was able to divide x, we can say non-prime. And how do you say non-prime? You return false. You immediately return false, right? So let's say you try to divide x with 2. We were not able to divide. We try to divide, like, let's see this example. Let's say x is equals to 7. Okay, let's say x is equals to 7. I starts with 2. Can 2 divide 7? Can 2 divide 7? No. We loop back and I becomes 3. Can 3 divide 7? 7 mod 3, is it equals to 0? No. So we again go back to the loop. I became 4. Can 4 divide 7? No. I became 5. Can 5 divide 7? No. We came to 6. Can 6 divide 7? No. And that's it. We just need to go till x minus 1. And that's it. If the whole loop has completed, and we were not able to find any number that divides x, can I say we will just return a true? Because if there was no number within this loop that can divide x, we can say x is a prime number. So let me explain it. If we exit the loop without returning false, means no number in range 2 to x minus 1 can divide x. Hence, x is prime. So we return a true. That's it. So if I have to bind this logic inside a function, what I can do is, I'll just copy this, paste it here, and I will say, let's write a function is prime. It will take a value x, and this is our logic. If we are able to divide x from 2 to x minus 1, we will return false. Otherwise, we return true. That's it. That's the logic that we have to implement. We will write a function is prime. It will take a value x. We will put a loop from I is equals to 2, I less than equals to x minus 1, I plus equals to 1. We will check if x mod I is 0, we return a false. Why we return a false? We found a number in range 2 to x minus 1 which divides x, hence x is non-prime. Otherwise, you return a true. If the loop, let me write a comment like this, the loop completed, but we didn't return false, that means no number in the range 2 to x minus 1 can divide x, hence x is prime, right? So if you try to run this code, console.log is prime. Let's check whether 11 is prime or not. So we get a true because 11 is a prime number. Let's say 12, whether 12 is prime or not. We get a false, 12 is not a prime number. Let's say 13, whether 13 is prime or not. We return a true. Let's say for 14, whether 14 is a prime number or not. We return a false. And that's how you can detect whether the number is a prime number or not. This is going to be a very simple code.